Well, everyone, we're gonna be redoing this. Sadly, last time we were doing it, we ran out of time, and sadly now we have to redo pretty much the whole thing. I spent some time catching up, and now we are back to where we left off. So here we are going to be doing different, editing different policies. We see that here in the default domain policy. In the default domain policy, we get to see that there are specific policies that are there, such as one of them being password related stuff. So in this case, since the GPO applies to the whole domain, whatever any changes that we make will be applied to everyone. So we're gonna start by making a change here in the default policies. We go to edit, and then we go down to user preferences, and then policies. Okay, and then administration, and then we go down to control panel. It would be add or remove program. Was it? Let's see. Password policies, which is under. Oh, never mind. We made a mistake. It's under computer configurations. Uh, let's see. Control panel. User. Is it? What is it? Oh. No, it's not administrative. Computer setting. And then what is it? Name, resolution, and then apologize, security settings. Oh no, it seems like I forgot. Okay, here, and then password policy, which we see that 7 characters. Our job here is to do 10 characters. Apply, and now press OK. So we went into computer configuration, and then after that went into policies, because this is one of the policies that is enforced, and afterwards went into the name, resolution, and then went down to security settings, in afterwards account policies, and then changed the password policy. Since these are policies on the computer itself, or the user's computer, workstation, whatnot, it will be enforced over there. So here now we can see that it usually takes 2 hours, but we can force it to take place right away. But in this case, since we won't have to test it out, we will let it run in the background. So in the next part is restrict access to control panel. So that's one of the other things that we will see many IT departments restrict for regular users. So we want to restrict access to control panel, restrict access to control panel for across all machines to only the users that are part of the IT department. Let's create a new GPO called restrict control panel access. So here we want to do is we are going to come out of this, and we are going to be creating a new one under let's see. This will be under group policy objects. We will right click. It's taking a little bit of time. We'll right click. Let's see. New. So this will be restrict control panel access. Perfect. And we are going to be editing it. In the edits, we will be before we do that, let's create a new one. Since we want this to be, we will look under user configuration. I see. Before we do any of that, yes, so we go user configuration, because it's the user, specific users, depending on their roles, they will not be able to access some of control panel. Now we go down to administrative templates, control panel. This is where I kind of messed up from the mixed it up from the beginning. Add remove programs. We see that one of the programs here is excuse me. No, actually, it's under the entirety. Is it prohibited access to control panel of PC setting? So we want to double click on it, and it will give us an option to enable the policy. So we press OK or apply OK, whichever is good. And now this is good on its end. And now what we need to do is we need to send this specific policy to everyone except IT. So everyone in the TryHackMe THM department except IT. So it would be the marketing department will get this policy. The management will get the policy as well, and lastly, sales. Sales will get this policy as well. So once we open these files, we dragged and dropped. We see that all of these departments have these policies enforced, which is good. So now we move on to the next policy, which is auto lock screen GPO. For the first GPO regarding screen locking for workstations and servers, we could directly apply over to the workstation, servers, and domain controllers OUs we created previously. Remember, we know OUs are organizational units, and pretty much those are pretty much groups that are policies enforced on, which is different from security groups, which we wrote down before. Difference between this and security groups is that security groups are there to grant permission, versus OUs are mainly there to apply policies or whatnot. So the next one is AutoLock. So while this solution would work, an alternative consists of simply applying the GPOs to the root domain. If we haven't already mentioned, GPO is the group policy management software, where we were able to enforce policies on different OUs. So since the workstation servers and domain controllers OUs are all children OUs of the root domain, they're inherited as policies. You might notice if our GPO is applied to the root domain, it will also be inherited by other OUs like sales and marketing. Since these OUs contain users only, any computer configuration in our GPO will be ignored by them. Let's create a new GPO, call it AutoLock Screen, and edit it. The policy to achieve what we want is located in the following row. So what are we doing? We're going to be creating a new one. So let's create it under policy objects, new, and we call it what? We have to call it auto lock screen. Perfect. And now we want to, where is it? We want to edit. And then when we want to edit it, it will be under computer configuration policies, since this is a computer that it will be auto locking or not. And then we go down to Windows settings, since this is something more based on the OS and the machine itself. So this policy is more towards the OS or kernel based policy. So now we go down to security settings. Afterwards, in security settings, let's make it a little bit bigger. Let's see if it's possible. Trying to hurry up a little bit. I'm worried that we might face problems like yesterday. Security options, which is under local policies here, local policies, and then security options, and we click on it. We go down to where it says interactive logon, machine inactivity limit right here. So we need it to be instead of undefined, we need it to be 300 seconds, as it says right here, and we apply and press OK. Now we'll set the inactivity limit to 3 minutes so that the computers get locked automatically if any user leaves their screen open. After closing the GPO editor, we will link the GPO to the root domain by dragging the GPO onto it. So this policy is going to be more for the entirety of the administration. So dropping it in the root, which is under thm.local, it will be applied to every single child OUs, which is like the computer servers and the domain controllers. And since this is a policy more towards the computers, it will mainly affect those. All right, sorry, let's take a water break. Okay, let's go. Let's see. We now check settings, and this generates the report. Policy. Oh. Why is that the case? We faced a similar problem like before, it shut off automatically. So we're going to be sadly redoing a little bit of the previous portions. Kind of remember what to do. Shouldn't be too bad. We just have to reinforce the policy of like, you know, auto lock and what and everything else. All right, right off the bat, recap. I'm just gonna pause right here and redo everything. All right, so we caught up. We added the auto lock screen into the root OU, which is thm.local, and it's supposed to automatically turn off the screen after 5 minutes. So we're gonna test it out. We will be going into the attack box, logging in as Mark, and Mark has a really strong password. You want to have your password as strong as that. We are going to be using RDP to log into the computer, and the RDP was, I'm gonna find out, sorry. Alright, terminal, it is X for DP, and the IP, which is target IP, it's 10.21.11.118.119. Alright, it is good, logging in, perfect. And now we're going to be logging in to Mark's account, so it should be thm/Mark. His password is marketing and .21. Where is it? M for RK 3T 1NG.21. Perfect. Strong password, and we are going to be trying. Okay. For some reason it still doesn't work. Remember, you can run update to force. Oh wow. Alright, so it says that if we try to open the control panel, we should get a message indicating that operations denied by the administrator. Please. Oh, perfect. It worked. It's giving us a error message saying that, you know, you can't really get in. And you can also try waiting 5 minutes to check if the screen automatically logs if you want. Since we did not apply the control on IT, it should still be able to log on to the machine as any of those users and access the thing if you want, if you create it linked. Okay, what is the name of the network share used to distribute GPOs to domain machines? What is the name of the network share used to distribute GPOs to domain machines? Can GPO be applied to use to apply settings to users and computers? Yay. Perfect. What is the name of the network share used to distribute GPOs to domain machines? Name of the network share. What was it? trying to refer back to it. Oh, I see right here. GPOs are distributed to the network via a network share called sysvol, which is stored in the DC, which is the domain controller. All users in domain should typically have access to the share over the network to sync their GPOs periodically. The SYS vol sysvol share points by default directory. All right, we make sure we remember that next. Well, perfect. All right, perfect. This root class is done. Now we move on to authorization methods. When using computer's domain, all credentials are stored in domain controller. Whenever a user tries to authenticate to a service using domain credentials, the service will need to ask the domain controller to verify if they're correct. Two protocols can be used for network authentications in Windows domain, one is Kerberos, used by any recent version of Windows. This is default protocol in any domain, recent domain, and the next one is NetNTLM, legacy authorization protocol kept for complicity purposes. All NetNTLM should be considered obsolete. Most networks will have both protocols enabled. Let's take a deep look. So we have Kerberos Kerberos. I hope I'm pronouncing it right. Authorization. Kerberos authorization is the default authorization protocol for any recent version of network. Windows users who log into service using Kerberos, we assign tasks. All right, so let's write it down so we have our notes. Kerberos is authentication protocols. Recent, we have NetNTLM, legacy. Both are present in most Windows systems. All right, so users who log into a service using Kerberos will be assigned tickets. Think of tickets as proof of previous authentication. Okay. Why? Oh my god. Okay. Okay, it's telling us we have an hour and 41 minutes. Okay. Sorry, I got distracted. All right. Think of a ticket as previous authentications. Users with tickets can present them to a service to determine they have already authenticated into this network before and are therefore enabled to use. When Kerberos is used for authentication, the following process happens. The user sends their username and timestamp encrypted using a key derived from their password to the key distribution center, a service usually installed on the domain controller in charge of creating Kerberos tickets on the network. So the user first sends their username and their timestamp. It's also encrypted using a key that is made pretty much using from the password, and it's being sent to the key distribution center. The KDC, which is the key distribution center, will create and send back a ticket generating ticket. funny name, which will allow the user to request additional tickets to access specific services. The need for a ticket to get more tickets may sound a bit weird, but it allows users to request service tickets without passing their credentials every time they want to connect to a server. Along with the ticket granting ticket, a session key is given to the user, which they will need to generate the following request. Notice the TGT is encrypted using the KRB TGT account's password hash, and therefore the user cannot access this content. This is essentially to know that the encrypted TGT includes a copy of the system key as a part of its content, and the key distribution center has no need to share the session key, as it can cover a copy by decrypting the TGT if needed. We see that there is a little diagram. First, the client sends their username and timestamp, which is encrypted using their password, something made from their password using the KGC, and the request is sent to the KGC, and then the KGC sends a request back with ticket granting ticket, and so that more ticket can be sent from the user. When a user wants to connect to a service on the network, like a share website or database, they will use their TGT to ask the KDC for a ticket granting service. Ticket granting service are tickets that allow connection only to the specific service they were created for. To request a ticket granting service, the user will send their username and timestamp encrypted using the session key, which is from the password, with the TGT, and a service principal name, which indicates the service and server name we intend to access. Pretty much saying that same thing: username, timestamp, and also the TGT, requesting TGT, and what server, pretty much service that they are looking for. As a result, the K distribution center will send a TGC along with the service session key, which we will need to authenticate to the server we want to access. So pretty much using the service session key, the service that we want to get access to, we are authenticating that we can get access to this. So the TGS ticket granting service is encrypted using a key derived from the service owner hash. The service owner is the user or machine account that the service runs under. So pretty much like the server, I guess, or the machine, and that holds that server. The TGC contains, let's see. The TGC contains a copy of the session service session key on its encrypted content, so that the server owner can access it by decrypting the TGC. Another diagram: its client sends the username, timestamp, and the TGC and the service that they're looking for, and then sends the request, the ticket granting service request, to the KGC, key distribution center, and then it sends a hash, service owner hash, and also the service that they're looking for through another TGC, ticket granting service, and then also they give us the service session key right here. The TGC can then be sent to the desired session to authenticate and establish a connection. Thus, service will use its configured account's password hash to decrypt the TGS and validate the the service session key. Pretty much, then the client takes the session key that the KDC gives it, along with the ticket granting service, goes to the service that it wants access to, using its username and timestamp. It seems that the username and timestamp are always there with their TGS, ticket granting service, and then using, as it says right here, the service will then use the configured account's password hash, which is the session key right here, to decrypt. Well, it already has this hash, session owner hash, since it's the service owner. It has a hash. It will take that key and decrypt it to validate if the key is correct. Now, if we move on to the more legacy option, which is NetNTLM authentication, also works. It uses a challenge response mechanism. The entire process is as follows. So the client sends an authentication request to the server they want to access. Client sends an authentication request. The server grants a random number and sends it as a challenge to the client. So then it sends that challenge as well as a random number. The client combines their NTLM password hash with the challenge to generate a response to the challenge and sends it back to the server. So the client already has a hash. Using that challenge that they get a response, and the response is sent to the server. The server forwards the challenge and response to the domain controller for verification. So once it has the challenge, it takes that challenge and the response that the client gives using the hash and sends it to the domain controller, just so the domain control can verify that the challenge and the response to that challenge is correct. So then the domain controller uses that challenge to recalculate that response and compare it to the original response sent by the client. You see, it does its own calculation. It checks if the results are correct and the results align. If they both match, then the client is authorized. Otherwise, access is denied. The authentication result is sent to the server. The server then forwards it to the client. Note, the described process applies when using a domain account. If a local account is used, the server can verify the response to the challenge itself without requesting interaction with the domain controller, since it has the password hash stored locally on its SAM. Will a current version of Windows use NetNTLM as the preferred authentication protocol by default? We know that it has both, but it says that while it should be considered obsolete, both have enabled. Let's take a deep look. So pretty much they both have it. So pretty much it should be a default that they have. So it should be an yay for an answer. Oh, we made a mistake. So will the current version of Windows use NTLM as the preferred? Oh no, it's not going to be the preferred. It will use both. They'll have both. When referring to the Kerberos, what type of ticket allows us to request further tickets, known as TGT, which is ticket granting ticket. Ticket. You send a ticket to get more ticket. Yeah, when using NetNTLM, a user's password transmits over the network at any point. No, the password doesn't go. It's more of the authentication request. I believe this is nay. Let's try it. Perfect. We got this perfect. All right. Let's move on to the next one. Let's see. Seems like we're getting close to finishing, which is good. It's taken up a good amount of time. So far, we have discussed how to manage a single domain, the role of a domain controller, and how it joins computer servers and users. As companies grow, so do their networks. Having a single domain for a company is good enough to start, but in some some additional needs might push you into having more than one. So what are trees in this situation? Imagine, for example, that suddenly a company extends to a new company. New country. The new country has different laws, regulations that require you to update your GPOs to comply. In addition, you now have IT people in two different countries, and each team needs to manage the resources that correspond to each country without interfering with one another. While you could create a complex OU structure and use delegation to achieve this, having a huge AD Active Directory structure might be hard to manage and prone to human error. Pretty much, we don't want everything under one AD. We want it to be separate. So lucky for us, Active Directory supports integrating multiple domains so that you can portion your network into units that can be managed independently. So pretty much it will have separate domains, and under that separate domain it will have different group policies and group objects and whatnot. And if you have two domains that share the same namespace, in our example it would be thm.local in our example, these domains will be joined into a tree. If our domain thm.local domain was split into two subdomains for UK and US branch, we should build a tree with the domain root domain of thm.local and two subdomains UK and US with each with its AD computer and user. So two different under one domain there'll be two different there'll be like a tree with two different subdomains, and each subdomain will have their own Active Directory, computers and users, so that they are different, like the rules and regulations are properly maintained. This partition structures allows us to better control over who can access what in that domain. The IT from the UK will have their own domain controller that manages the UK resources only. For example, a UK user would not be able to manage US users. In that way, the domain administrators of each branch will have enough complete control over their respective DCs, domain controllers, but not other branches' DCs. Policies can also be configured independently for each domain in this case. A new security group needs to be introduced when talking about trees and forests. The enterprise admins group will grant a user administrative privileges over all of its enterprise's domain. So pretty much everything in that tree. Each domain would still have its own domain advisor with administrative privileges over their single domains, and the enterprise admins will now who can control everything in that enterprise. Pretty much someone is pretty much like the head of controlling all the policies. Now we move on to forest. The domain we manage can also be configured in different namespaces. Suppose your company continues growing and eventually acquires another company called MHT Inc., which is pretty much like backwards of THM. When both companies merge, you still have different domain trees for each company, each managed by their own IT department. The union of several trees with different namespaces into a single network, into the same network, is called a forest. So if you have multiple trees in one network, it is considered a forest. I mean, makes sense. So now, what is a trust relationship? So in this case, within the different different trees and forests, it should be trust. Having multiple domain organized in trees and forests allows you to have a nice compartmentalized network in terms of management and resources. But at a certain point, a user at THM UK might need to access shared files in one of MHT Asia servers. For this to happen, domains arranged in trees and forests are joined by a trust relationships. In simple terms, having a trust relationship between domains allows you to authorize a user from one of the domains to access information or resources from the other domain. The simplest trust relationship that can be established is a one-way trust relationship. In a one-way trust, if domain AAA trusts domain BBB, this means that a user on BBB can be authorized to access resources on AAA. So someone from AAA trusts B, then B can access. It's a one-way. So if A trusts B with accessing information and resources, then B is able to do so. The direction of one-way trust is contrary to that of a access direction. Two-way trusts can also be made to allow both domains to mutually authorize users from the other. By default, joining several domains under a tree or forest will form a two-way. So two-way is more of default. It's important to note that having a trust relationship between domains doesn't automatically grant access to all resources on other domains. Once a trust resource is established, you have the chance to authorize users across different domains. But it's up to you what is actually authorized or not. Alright. What is a group of Windows domains that share the same namespace? If they share one namespace, but they have different sub domains, they are trees. Perfect. What should a configured what should be configured between two domains for a user in A to access a resource in B? So it would be a trust relationship. A trust relationship. Perfect. Finally, we are done. Good thing this we completed all of this, all the information, all the, everything here before we lost our time. Oh, it's still letting me. Oh, that tag box ran out of time, but I have almost an hour in the basics. All right, perfect, which is good. In this room, we have shown the basic components and concepts related to Active Directory and Windows domains. Keep in mind that this room should only serve as an introductory to basic concepts, as there is quite a bit of explore to implement a production-ready Active Directory environment. For interested in learning how to secure active installation, please check out the hardening room. If on the other hand, you know how attackers can take advantage of common AD misconfiguration and other AD hacking techniques, the compromising Active Directory model is a way to go. So from our understanding, we know that the Active Directory is very important, and pretty much Active Directory houses all the users, machines, and computers and everything. If a proper policy is not there in an Active Directory, it can cause problems. If users that shouldn't be there are there, they will have access to a lot of company resources. Someone can be given special requests, special authorizations, delegating to make sure that they're able to take care of it. And then there are policies that are enforced. These policies are there just to make sure that all of the people, users, computers, everything under that administration is properly adhering by that policy. And those policies can be enabled, enforced, and taken care of really easily. So that is it for this module, this room. This was a great room to get a good understanding of the Windows Active Directory itself. A lot of different companies are currently relying on Windows, so knowing their Active Directory and how the whole process of it is very crucial when it comes to understanding the main roles or just roles in general for someone who works in the IT support or IT help desk. So thank you so much for bearing with me. The video is probably going to have multiple parts. Sadly, we faced a few issues because of the fact that it ran out of time, shut off, or sadly whatever happened, and time differences. There will be multiple parts, and I really, really do hope you enjoyed this video, and I just hope that it's something that I can take from and it can stand as a way for you to understand my skills. Thank you so much.